Hello, ladies and gentlemen, to our first online lecture of the year, and welcome to our first unit on properties of matter. So this lecture is going to focus on two of your learning objectives. You can identify why all samples of a substance have the same intensive physical properties, and that you'll be able to differentiate between the main physical states of matter, and identify the process by which a sample transitions between each phase. So to start our conversation today, you will need your textbook. Yes, your textbook. Remember that you can access it through the cloud. So I'm going to give you a moment. Make sure that you have gotten to it because we are going to discuss this information next class. This is what I'm going to start the class with. So this is going to be a quick indication on whether you actually listen to the audio of the online lecture or not. When you find out what you've chosen and recorded those, you're going to write those in the top right corner of the notes page. So I'm not going to wait for you, but you should pause it here and then go read that part. Okay, now that you've read that, two questions for you. So as you consider the situation with the fish tank, what other substance shares the property of transparency with glass? Okay. Why do you think glass was chosen for the aquarium window rather than plastic? So one of the biggest things about chemistry is we study the properties of matter because we need to use matter to make our lives easier. We're daily working with different types of substances, and we're trying to use them in the best way possible and the safest way possible. So how will knowing the properties of the matter help us be able to use things in our lives more efficiently? So to begin describing forms of matter, one of the first things we identify is physical properties. So the biggest thing that we're looking at is how we measure the property to distinguish what kind it is. You'll notice that it's one that can be observed or measured without changing the composition. So if I don't have to change the substance's composition to measure this property, it would be considered a physical property. They're broken into two different categories. Extensive, you should think of as external. You're taking the measurement kind of from outside the substance itself. So how much is there matters. If I take the mass, how much it is will change the mass of the substance. The volume will change if I have more of the substance. Intensive should make you think inherent or internal. These properties come from the actual type of matter you have, and no matter how much or how little of it you have, that property will remain the same. So an example would be absorbency. If you think about a basketball, a rubber basketball is going to maybe stay wet with some of the materials if you're playing outside. A leather basketball, because of the material it's made of, can actually absorb some of that moisture. Consider something like color. If something has a particular color, whether I cut it into little pieces or maintain a larger sample size, that color is due to the properties of the dyes or the compounds inside that substance. We're going to use the term substance to describe many different materials that we work with, but when we use that word, we're specifically talking about something with a uniform and definite composition. So uniform means the same. And definite is getting at the idea there is a defined composition of elements and compounds within it. So no matter what sample I take out of it, the properties will be the same because all of the composition is the same. Aluminum and copper would be two examples of elements that fit this criteria. So if we take a look here, this is our physical properties. This meets our information for objective number 1. So we have two different categories of physical properties, both extensive and intensive. Being sure to be able to distinguish between them and give examples is important. Our work this unit will give us more examples in our labs. and understanding that a substance does have that uniform and definite composition. So when we talk about substances, there is a specific definition tied to it. Now, one of the things we can describe for physical properties is the state of matter. So that's why it fits in with this conversation. When we look at this animation, it does a great job of showing some of the particle movement and the energy associated with each of these states. So a gas is our highest energy particles. Because they're moving around so much, they will fill their container. And they're bouncing around off each other, so they're very far apart. Because of all that space, they are easily compressed. You can actually push the particles closer together. Think of aerosol cans, fragrance things, hairsprays. The reason why you can shove so much product into those containers is because the gases can be pushed closer together. Now, a liquid still has that indefinite shape because the particles can flow and move past each other, but they don't have enough energy to separate from each other. There are still attractions holding them together. So they will take the shape of their container, but they won't fill it. Can you imagine that? Like putting water into a glass and suddenly the water expands without adding any more? That would be kind of crazy. Because they are so much closer together, they are almost incompressible. They may be able to be compressed a little bit, but very, very little. As they are heated, the molecules or particles will start to spread apart. A solid, on the other hand, has the least amount of energy. The attractions are so strong because there's so little energy that the particles are held essentially in place. What this diagram I think doesn't show well is that there is still some vibrational energy. So this diagram or animation would be better if it showed them kind of wiggling in place. So they still have some energy, they have movement, but very little. Because of that, they hold their shape and they will not take the shape of their container. Now, if we were to move between the different states of matter, that would require a change in energy. So if I wanted to go from a gas to a liquid, what would the particles have to do? They would have to slow down. So if I was going to transition from that gas to a liquid, energy would have to leave the particles and go to the outer environment. If I wanted to start at a solid and work my way towards the liquid and then the gas side, energy would have to be gained from some source to add in enough energy to break those forces of attraction holding the particles together. When answering questions on assessments or being able to explain the differences between the states of matter, the energy of the particles is an important point. So make sure you're able to explain what the energy is doing depending on which way you're transitioning. With that, that finishes up the part of the notes that you are responsible for with this video. Make sure that you note any places that you have questions so that we can discuss them in class.